Hello, mathematicians. Final episode 6 for band 6. We are looking at analysing data. Now, I realise making this course of videos, when I watch YouTube videos, I hate it when they spend the first minute or two just talking about what the video is going to be. I'd rather I always skip it and get right to the point. So I've learnt that, and so apologies for it taking up until the last video to do that. And you know what? I'm doing it right now. So all I want to say before I do start the video is analysing data. It's not just data and statistics. I'm actually incorporating linear relationships in this because a lot of the time when they graph a straight line, it's based on data, okay? So they link together pretty well. Anyway, let's start. Okay, that was pretty good timing, I think. Analysing data, here are the 5 main parts I'm breaking it down into. So, straight lines. Look at that, I flew through that. What an interesting video this will be. Okay, straight lines. Important thing to note is you've got the equation of a straight line is always in the form of mx plus c. Sometimes you'll see it as b. M is always your gradient. Remember, that's your slope. Positive. Put your little bike on the right-hand side of the page and it's going to be going up the hill versus down the hill will be negative, okay? Remember, a flat line is 0, has a 0 gradient, but a perfect vertical line is undefined. We don't say it's 0, it's undefined. All right, the constant on the end is always your y-intercept, so where it crosses your y-axis. If you need to find your x-intercept, remember, let's say we have the line 2x plus 1. To find the x-intercept, we make y 0. Okay, so then it's just a matter of solving this equation. And when you solve that, minus your 1 divided by 2, you'll get x equals negative 1/2. Okay, so if I had to graph that line, now I know the 2 points. It goes through the y-intercept at 1 and x-intercept at negative 1/2. Join them together and there's my straight line. Remember, to draw any straight line, you can do your intercept method like I just did, or plot a table of values, okay? So just pick some random x values, minus 2 up to 2 is always good, and plug them into your y. All right, the thing you need to know is how to find the gradient. You can find the gradient in many ways. If I said to you, what is the gradient of this line? That's finding the gradient. Hopefully you'll say m equals negative 1 because remember it's always the coefficient of x and it's negative 1. Another way they can ask you is if they give you a picture. If they give you a picture, always do rise over run. When we do rise over run, we make a triangle out of 2 points we know. Remember those 2 endpoints of the triangle we need to know. So for instance, I wouldn't do the triangle here because I don't know this endpoint there. Okay, so it must be 2 endpoints I know. So here's my triangle. Remember, it's really the same thing as the height of the triangle over the length of the triangle. So for this one, m is equal to, my height is going to be 7 and my length is 3. So 7 on 3. And always put your bike on the page. It's up here this time. It's going downhill, so the final gradient is negative 7 on 3. So if they said, what's the equation of this line? Then it's just a matter of going, oh, well, I know that it's going to be y equals negative 7 on 3x because that's my gradient, plus the y-intercept, which is positive 5, so plus 5. And there's the equation of the line. So then they could say, well, what's the value of y when x equals 10? Okay, so you could estimate it by following out to 10 and drawing a line down, or just sub in 10 into your x. Okay, so it's linking a lot of things together. So the way it relates to data is a lot of the time in HC, a line like this will be let's say the what could it be? Number of the population of ants decreasing over time, and it's perfectly straight line. Unlikely, but first thing popped into my head. So this graph could represent the population of ants over hundreds of years. Okay. All right. The last part when you're dealing with your data in your straight lines is if they give you table values, finding the rule. We did quite a bit involving all this, so I just want to quickly recap it. Remember, a straight line is always in the form of something, x plus or minusing something, and we represent it as m and b. To find m, which would be going in front of the x here, it's whatever your bottom row is going up or down by each time. Okay, so this one is plusing 6 every single time. Okay, so it's positive 6 in the first box. Then the second box here, remember that's your y-intercept, which means it's whatever is under the value where x is 0. So now I just need to fill out what goes under 0. It's going to be, subtract 6 there, it'll be 12. It's positive, so it's going to be plus 12. So the equation of this table values is this. Okay, so bottom row, whatever's going up and down by, then whatever's under 0. Okay, let's keep moving forward. Lines of best fit. Okay, there's 2 ways to find a line of best fit. Okay, you can find the equation by I, which they often get you to do. Now, if you have a scatter plot, okay, and you have all of your points, when you're drawing your line of best fit, remember, you want to try and put the line so there's the same number above, dots above the line as below. If you go through some of the dots, even better. But the main aim is to get the same number above and below the line. So when you're putting this line in, and I won't spend the time now doing it, it's just a matter of trial and error and, you know, use a pencil, put them in and then count how many dots are above your line, count how many dots are below the line and adjust it accordingly, okay? Once you have drawn it by eye, then it's a matter of finding the equation of it by eye. And that's just filling in this, okay? So it's a graph. I need to find m, which is my gradient, okay? So on a graph, to find the gradient, and they would always give you like grid points and values, okay, to go on here. So when I'm doing this, it's just going to be rise over run. So to find your gradient, do your rise over run. Now remember, when you're doing it by eye, it's only an estimation, okay? So pick 2 points that definitely pass through grid points and do your rise over run wherever you need to and find the approximate gradient for that line. The second one is your y-intercept. Now perfect, if this passes through at 0, you can read off whatever it went through here. It might be, say, -1, looking at this graph, okay? But a lot of the time, it's not that simple. So if it goes through your axes, just read it off it. However, a lot of the time on these application questions, what they do, just to throw a spanner in the works, is this point, it might be 80, 90, 100. Say this is, I don't know, analysing how many people got different marks in their HSC for maths. And so there was 20 people that got 80% and 30 people that got 90%. So what that means is this is actually 70 here, not 0. And they do it quite a lot. So it's where they've not done it all the way back down to 0, they're just showing you part of the graph. So if they do that, so it's not 0 on your axes, it's a number. All you need to do then is pick a point on your graph that your line goes through. So whatever this point here is, let's say it was, well, I could say, let's say it's 95, 40. Once you know your gradient, let's say the gradient of this one was 10. What I know is it's 2x plus b. So far I would have had that. If I know my gradient, now I just pick my point, 40, 95. So I sub 40 in where y is and 95 where x is and rearrange that for b. Oops, that should be a plus. So 2 ways to find your y-intercept. Method number 1, if it passes through the y-axis at where 0 is, read the number and put it in. If it doesn't pass through the y-axis where 0 is, you need to pick a point and sub it into the equation with your gradient in it, okay? You need to know your gradient first. Now, When it comes to on the calculator, I'm going to come back to that because further down we look at just calculator maths and there's a nice little summary for it. But when they talk about on the calculator, it's least squares line of best fit. It's got a few names, but least squares is one, least squares regression. So when they ask you to find the least squares regression line of best fit, or least squares line of best fit, it's on your calculator, and this is the accurate version. So your calculator, if you put all your values in, it will give you the actual M value and B value for your equation. Okay, so I'll show you the little summary on how to do that in a second, but just be mindful when you're calculating the line of best fit, there's two ways. Look carefully at what way they ask you. However, if all else fails, you can always go back to just your accurate way. So if they ask you to do it by eye, I'd still, if I have the time, do it the calculator as well, and then just make sure you're roughly close-ish. All right, so here's an example question. Pause the video and give this a go if you like. Otherwise, let's have a look. Determine the gradient. So this is just putting everything I just mentioned into a question now. So I need the gradient. So what I do, M equals rise over run. When I do rise over run, I draw a triangle. When I have my triangle, they need to be through 2 points I know. So I can see this point here is a perfect point to pick. It perfectly passes through there. Another point that would be good to pick, what does it pass through? There's a few there, but it also passes quite nicely right smack bang there. So here's my triangle. The other one I wanted to remind you of is if you get given 2 points, you can also use this formula for your gradient. Okay, so I'll show you how you could use this here. This point, the first point I know it goes through is 15,170. And the second point over here I've said is 11. And then what are these going up by? 2, 4, 6, 8 twos. So 140, 2, 4, 6. So there's my 2 points. So I could just plug them into my y2 minus y1, x2 minus x1. Just remembering little things, like don't make it a silly error. This is going to be your y1, x1. So this is point 1, this is point 2. So this is x2, y2, and subbing it in. The other way to do it with your rise over run, look at what it's rising by, okay? So it's gone from 146 up to 170. You can see, hopefully, how they actually are nearly the exact same thing, really, okay? So putting it in, I'd get 170 minus 146 over 15 minus 11. And again, it doesn't really matter if this is 0.1 and this is 0.2 or vice versa, okay? All right, and that will give you your answer. So you get, what, 24 on 4. So the gradient is 6, and it's positive, so it's positive 6. So then I say, therefore, M equals 6. So explain the meaning of the gradient in the context of the data. Great question. It wants you to really understand what this means. So this says the height, age and height in males. So when they age, their height. So what I would say then is every year they grow older, their height increases on average by 6 centimeters. Okay? So relating it back to the context. And then determine the equation. All right, great. So I know I need y equals something x, which is my m, plus or minusing my gradient. I already know m, 6x. What do you know? This is exactly like I was saying before. Notice how this isn't 0. So that's not my axis. Okay, so I can't just extend the line down and then read off it where it might look. I must pick a point. I already have 2 points up here. So I'll pick, oops, I did not mean to do that. I'll pick one of them. Let's do the first one. And I'll sub it in. So I've got y equals 6x plus b. So putting it all in, 170 equals 6 lots of 15 plus b. So the answer will be whatever 170 minus 6 lots of 15 is 90. And there's my v value, and then I have my equation. Okay. Let's keep going. Quartiles. I just wanted to remind you of a few things with these. Q2 is the same thing as your median. Q1 is the median of the top half, Q3 is the median of the bottom half. Inner quartile range is Q3 minus Q1. On a box and whisker plot, this is what it would look like if they ask you to construct a box and whisker plot. You got your box in the middle and your whiskers going out to it. The whiskers go out to the lowest and your highest score that are in the data. Then you've got Q2, 1 and 3 all listed on the box like this. Remember about the 25% rule. So this amount of data is 25%, 25%, 25. So they might say, what percent of data is below 3? And if 3 is Q1, you say 25%. Or what percent of data is above 3? And you say, well, 75%. Okay. Then the only other thing is outliers, and that's what's in blue there. Okay. So an outlier, you get given these formula. It says that you take Q1 and subtract off 1.5 times your inner quartile range. Okay. So basically, wherever that lands, so let's say it lands in here, then all the scores less than that are outliers. The same thing here. 1.5 times inner quartile range, that number, you plus it with Q3. And wherever that lands, everything above that will be outliers. So what happens is if it lands out here, so let's say the highest score in the data was 20, but you get an answer of 30, it means there's no outliers because none of the data is above 30. Okay. The last little part with the quartiles just to be mindful of is if they give you, and only if they give you, a cumulative frequency graph. Remember, that's where you have your scores down the bottom and your cumulative frequency going up. Not frequency, cumulative frequency. Whatever the highest value is, so let's say this is 200, you halve that, okay, and get 100, which would probably be around here. You draw a line straight out to your ogive and straight down. If you don't have an ogive, it's just straight out to your histogram and down. And then this might be the score of, what do we have? 1, 2, 3, 4, score of 5. So your Q2 equals 5. So then Q1 is going to be at 50. So draw a line straight out. Here's that. So Q1 equals 4. And Q3 is going to be at 150. So draw your line straight out. So then Q3 is going to be at 6. So then my inner quartile range is 6 minus 4 is 2. How easy is that? So just be mindful that can happen as well. All right, just the calculator work, okay? So if you don't have a copy of these, pause the video and write it down. I'm not going to go through it, but it just explains how you can find your Pearson's correlation coefficient and your equation of least squares regression line, okay? Be careful on your least squares regression line. It's just frustrating, but they do it the other way around. So when they give you the answer to A, it's your y-intercept, and the answer to B is your gradient. So that's what just this little thing here says. Okay, there's plenty of YouTube videos too. If you don't understand this little formula summary I've given you, just type in Pearson's correlation coefficient on a calculator. And last one is your normal distributions. What you get given on your reference sheet is this little image here, but what you must remember how to calculate are the little values. So the first one, it says that 68% is in between 1 and -1, which means, nice and easy, 34% in here, 34% in here. Then it says 95% is in between 2 and -2. So what I need to do is I say, okay, 95, I take off my 68, and then I need to divide that by 2 because I need what each one is. So dividing that by 2, you get 13.5. Okay, so this is 13.5 and this is 13.5. So then you do the same thing. 99.7 minus 95 all on 2 is going to give me the final ones out here, which we will get an answer of 2.35. So then you get 2.35, 2.35, and then, oops, the final one, I should check it, but the final one is 100 minus 99.7, all on 2, and let me just double check it, but I'm pretty confident you get 0.15. Yep, you do. So as soon as I get a normal distribution question in my HSC, I would draw my little bell curve and put all those numbers in. You got two options. Remember the numbers off by heart, or remember how to calculate it based off this information that you get on your reference sheet. Okay, guys, that is what I'll just recover for you in those questions there. Let me know if you have any questions or want some more questions to practice on this. And good luck.